Alright, let's see what we'll do today. What my plan for today is basically solve this trapping rainwater question, which is a Leetcode hard. I have solved this question in the past, but I don't exactly remember what this question was or what this is about. And then I'll continue to update my resume on live stream because I haven't updated in a really long time. So yeah, that's what I'm gonna do today. So let's start the stream, I guess. And yeah, cool. First things first, we do this. Cool. Let's see. Given in negative integers representing an elevation map with the width of each bar is 1, compute how much water it can trap after raining. Alright, so we have height of every single map. We need to check how much rainwater can be trapped after raining. Right. So okay, alright, let's see. For example, we have 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. This is what we have. This is the let's say first high altitude. This is the next high altitude. We can only store water up to this height, right? Yeah. All right, we have height over here. This is my graph. What are we doing? We start from here. This has a what? 0. Then we go here. We store this 1 and 2. 0, 2. stored over here, then it goes to 1, then it goes 0, then it goes 1 again, then it goes 3, right? Up till here, we can store water at this level. We have this and this. All right. All right. What we need over here is this array, right? What can be the approach? It stores 6. What can you tap? Okay, it stores 6 is the amount of water that we're storing. Like 1, 2, 4, 5, and 6. Yeah, got it. So, okay. Let's say for at this index I am over here to that 0, 1, 0, 2, 1. At worst index, what is the like height that we are storing it? It is 2. The right height that we are going at 3. Alright, so we take min of both. Yeah. And then you subtract the height of this. That's how much water you can store. So why I'm saying about left and right boundary, for example, for this I come, it is 1. It is 2 for this, right? So it's like that, right? So what do we do? And we take minimum of those boundaries, and that obviously will take minimum because otherwise it will overflow. The water will overflow, right? So we need to take minimum of both of these boundaries. Now how do we check? Okay, what if Can we do this? How do we do it? What is the boundary for this index basically? It is the next maximum point, right? Like for this point, let's say for this point, it will be the next higher point than this, right? That will be the boundary for this. For this, it is nothing. For this, it is this. Right, but it will flow from here, this side, so we can't store anything at 0th index. Right, then we go here. All right. Oh, all right. What do we do? How do we pre-calculate the right and left boundary for this? Let's see. Okay, but how to do this is the question. Alrighty, alrighty. See, the base thing is that happy Oli bro. Same to you, man. Got it. All right. This is the basic format, right? The finding line. Right. Calculating. This will be what? All right. We only care about the minimum height of this, right? Need minimum height, right? So it will be left max of I. Right, max of I for minimum. And what do we need? Out of this height, we need to subtract the current height. And this should be the final answer, right? Let's try and run it for the whole question. And yeah, yep, it works. But can it be more optimized? I don't know that. Let's see. Like, can it be more optimized in any way? Hey, hi Lakshay. Alright, it's also using stack. How do you stack in this? Is you check current height. If it is greater than stack dot peak, you okay, I need to see this. Alright, this is the most optimal answer actually, which is a two-pointer solution. I solve daily actually. I don't know. Let's see. Sometimes I don't just because of some office work or anything like that. But yeah, I generally try to solve it daily from past few days. See, I tried to be consistent in the past few days, but sometimes I do miss it. Uh, okay. What's happening over here is you get this and lift max is this. All right. And the right max is this. Okay. And if lift max is less than right max, you do this. Otherwise, you do this. All right. Makes sense. Actually, it makes sense. Let's see the video once.
Hey everyone, welcome back, and let's write some more Leetcode today. So it's been a while for me, sorry I've been pretty busy, but let's today solve Leetcode 42, trapping rainwater. So we're given an integer array representing the heights of certain elevations or whatever, right? So it's a one-dimensional array, value is 1, so that means a height of 1. Some have heights of 2, this one has a height of 2, this one has a height of 3, right? And so given this entire structure, we basically want to know, what's the maximum amount of rainwater could this structure trap, right, given an unlimited amount of rain. So you can see this is 1 unit right over here, this is roughly 4 units, right? 1, 2, 3, 4, and then this is another one, right? So when you count all of those, you get a total of 6 squares, right? So the output is 6. This can trap a maximum of 6 blocks of water. So with a picture, it's pretty easy, but how do you know, right? Like, what's the algorithm to determine how much each position could trap, right? Like, for example, this position is the first one, right? So there's no boundary on the left of it, right? So no matter how much water we would add over here, it would all just spill to the left. And the same is true for this position, right? No matter how much water we put on top of here, even though there's a right here we have 1 block of water. What if I added a second block of water? Well, we can see that there is a boundary on the right. This is good, right? But what about the left side? There's no boundary over here, right? Meaning any water I add is just going to spill out. The boundary only has a height of 1. So we're seeing that the height on the left is 1, the height on the right is 2. So we need to take the minimum of that. We need to take the minimum of 1 and 2 because that is our bottleneck. That is what's determining exactly how much water we are able to trap per position, right? For every single position, we need the max height on the left and the max height on the right, left and right, and then we need to take the minimum of those two. Let's take a look at this position. Clearly, we can't trap any water here, but why exactly is that the case? Well, when you look at the right position, right, in the entire right section, the maximum height is a 3, right? So that's good, 3 here. What's the maximum height on the left side? It's a 1, right?
The person who made Leetcode blindsided by his resource. It is pretty good. Do you mean this Leetcode guy? Do you mean this Leetcode sheet?
This position is a 2. If we take the minimum of 1 and 3, we get 1. So that's our boundary. That doesn't mean we can trap any water here. We can trap 0 water here. The reason is because the actual calculation is we're going to take the minimum. We're going to take the minimum of the maximum left height and the maximum right height. We're going to take the minimum of those two, and we're going to take the height that we're currently at, right? So let's say h of the index I that we're at. So this is the equation we're going to use to determine at every single position I, let's say this is our I position, right? So you can see I is in this equation. This is going to be the minimum of the max of the left and be is that's actually 1. We're never going to use negative sense in this position. But let's just move to a couple more positions before you probably get, and is 3 water count. So these are water that we can trap. Once we take the sum of all those, we are going to get our answer 6.
Oh, which guy can you mention it?
So now let me actually show you the efficient ways to solve this problem. Okay, so I'm going to show you two different ways to solve this problem. Both of the solutions are linear time solutions, right? So big O of n is going to be the time complexity of the solution, but the first solution I show you is going to actually require big O n of memory as well. There's an actual optimization you can do with 2 pointers to reduce the memory from linear memory, big O of n, to constant memory. So I'm going to show you both of the solutions, and it's actually not a lot of code. The code is actually pretty easy. Since for every single position, right, to know how much water we can trap at index I, we need to know what's the max left and right height of every single position, right? So for this position, the max on the left is going to be 2 right over here, and the max on the right is going to be 3 right over here, right? So we're going to need to be doing that calculation a lot. So we can actually make an array and then store that calculation for us so that we only have to do it a single time each. So first we can scan through the array, right? Just go iterate through the entire array, calculating every single max left position, meaning for this position, what's the max height on the left of it? Well, there aren't any heights on the left of it, so it's going to be 0. What's the max height of this? Well, the max height is 0, right? That's the only height that came before it. What's the max height on the left of this? Well, it's a 1, right? So we can do this in linear time, big O of n time. So I'm just going to do that, right? What's the max height on the left of this? 1, max height on the left of this. So for max, we go from right to left, max right of the values, right? Because the minimum is going to help us determine how much water we can trap in this position, right? And clearly we can actually find the minimum of these two arrays as well in linear time. So here it's the minimum is 0, minimum at position I, right? Add the 0 to the negatives. This is going to be this extra memory that we just allocated. We're actually going to do this. We're going to do this with 2 pointers. So initially I'm going to have my left pointer over here. I'm going to have my right pointer here. So the right pointer is going to be all the way at the end of the input array. So we're going to have our 2 pointers initialized. We're also going to have 2 variables, max left and max right, which are going to be keeping track of the maximum left pointer and maximum right pointer so far. So you can see left is initially 0. So the max so far on the left is 0. You can see right is initially 1. So the max on the right so far is 1. So now we are going to have to update our pointer. Now, which pointer are we going to shift? We're going to take the one that has the smaller max value. So right now you can see max left has 0, max right has 1. So we're going to shift the smaller one, which is left. So we're going to take our left pointer and shift it. So now our left pointer is over here. And just a FYI, we know that we can't have any water stored on the endpoints, right? On the left and the right positions, we can't have any water because they're endpoints, right?
No, I meant the person who made Leetcode blind 75 questions. The person runs the website called Take Interview Handbook. And so, okay, let me check it out. Yeah, I'm checking it. Okay, you're talking about this one. Oh, this is the guy. Yeah, this is the guy, no? This is the guy you're talking about, right? Just follow him. Oh, that's a pretty good resource actually. I didn't see it on my own. Thanks, man. It's really good. I just bookmark it. Where can I move it? I don't think I need this. Okay, I don't need this. Yeah, I can actually feel it. It feels pretty good, to be honest. Cool, I'll go through this for sure. I have bookmarked it, so yeah, I'll definitely go through this, man. Thanks a lot.
Right? They can't contain any water. But this position technically can have some water. And how are we going to determine that? Well, we're going to take how much water this can contain, right? We're going to take the max left value that we have in our variable right now, right? How come we don't need the right value? Well, I'm going to show you. So this is the part that you kind of need to notice the trick, I guess, right? So we're in this position, right? Now, remember originally we wanted the minimum down here. You can see we wanted the minimum of the max left and max right. Well, we know what the max left is so far, right? The max left is 0, right? That's what's over here. Now, we technically don't know what the max right is, even though this variable says 1. Yes, so far it's 1, but we know that the max right could actually be 3, right? That's what the true max right is of this position, right? Because there's a 3 over here. So why is it that we don't need that value? Because remember, we want the minimum of the max left and the max right. Now we clearly know that the max left is 0, right? So it's smaller than what's even at this position, right? And we want the minimum of it. So no matter how big this value is, right? Right now it's a 3, it could be a 10, right? It doesn't matter how big it is because we want the max of the left and the right, and we already know that the left is pretty small, right? It's 0. So it doesn't matter what's in all of these values because we know that the max left is our bottleneck, right? Remember, we shifted our left pointer from here to the next position because left was smaller than right. That's why we shifted it. That's how we're able to calculate the water that's trapped in this position without knowing what the max right is. So with that being explained, let's actually go through this so we can get to the code. So what's the amount of water that we can trap over here?
Alright, this makes sense actually. Like the code also makes sense now. Awesome. Alright, I guess that's enough lead code for today. Like I mentioned, I would do one lead code hard and I'm done with it. Now we can move on to editing the resume, I think. Let's do that now. Okay, any resource to me? What kind of things are you looking for right now? Like, as in, what are you learning right now? I would definitely tell you any resource if I know any good resource in that domain. So let me know what are you looking for as of now. Backend stuff, all right. Let's see. I remember we talked about learning advanced backend stuff, right? Uh, you're done with what right now? You're done with merge stack as of now, right? Like, yeah, lead code, it is definitely questions practice. Nothing else. If you wanna learn about advanced backend stuff, I would recommend like okay, for system design there's Arpit Bihani on YouTube, right? For backend you can follow Piyush Garg. Piyush Garg is a really good guy. Like he explains stuff in a really easy language and he's really good at advanced backend stuff teaching. So me myself learned Redis from him and I also cleared my basics of Kafka from that guy. So I find him pretty much enough for advanced backend stuff. Like for getting a hold of initial things required in advanced backend, other things you will learn on the way when you develop things or when you work at an organization. That's when you learn the proper mechanisms of microservices. Like every org has a different, what you say, architecture, right? So it depends on org and org. But if you want to clear basics, there's Piyush Garg on YouTube. If you want to study about system design, there's Arpit Bihani. Then yeah, Kafka Redis. The Redis का तो even documentation is really good. Like if you see, तो Redis का Redis का own documentation is really good. You can easily learn Redis from their own documentation. Like let me do this. Yeah, yeah. If you go through their docs, it will be really easy for you. Is JS interview playlist? Okay, I don't know about the JS interview playlist yet, but yeah, yeah, he's really good at teaching stuff. Like his way of teaching is really good. So yeah, Redis their own documentation is good. I think it is pretty much enough for you if you wanna clear about server-side caching. There you go. They're using Redis, but just a tip from my end: if you're using Redis in any of your microservice, like in your Lambda functions, don't go for this Redis library, Redis package. Instead, go for IO Redis. Like this is the package that I recommend for using in your serverless architectures or in Lambda microservices, because it is really good in serverless things. Like the Redis Wala library actually crashes sometimes in Lambda function, so that's why I don't prefer using it. So yeah, let's continue editing the resume now. Alright, first of all, I need to change projects. Sure, man. We'll be happy to see the progress actually. Like the reason why I started live stream was this only, to grow with the community, because you get to know a lot of things from others also. Alright, first of all, I'll not use this project anymore. It'll be what it can be Quizzy. It used what Golang, Redis, MongoDB, Docker. Good night, man. Thanks for watching. Let's see what all things I have done over here. right, what can we reduce over here now? Let's first of all, let me do one thing over here. Okay. Okay, this is a redundant point, right? Yeah. Okay, let's see this. Alright, let me do one thing. Alright, I'll be back in a minute. Cool, I'm back. Let's see. What else can we add? I think we can write it as this. Okay. What else can we add? Let me see. Alright, I guess that's it for the resume thing right now, as of now. Yeah, I'll be adding my mobile number off screen and then I'll be downloading it. So yeah, thanks for watching. And wait a second. Yep, cool. Thanks for watching.